Algebra 2, section 7.2 we're dealing with inverse functions. So basically in the last section we were dealing with combining functions in very different ways to join them together. In this particular one we're going to find the inverse, the opposite. And we've done with inverse fractions, so if you know the inverse of 1/3 is 3 over 1, the inverse of 2/3 is 3 over 2. In this case, we're finding inverse for an entire equation, and the rule is, and the inverse means, so if I have 3 over 1 and 1 over 3, they're inverses because if I multiply them together, I get 1. 2 over 3 is the inverse of 3 over 2 because if I multiply them together, I get 1. Well, in this case, it's very similar. But remember the composite, you know, the equation eating the equation from last section? If I find the composite of an equation and its inverse, everything should cancel out except an x. And if I do the composite, the opposite, like the inverse of the original equation, then I should get an x. So if everything cancels out in the composite of either way, I should get an x, and that means that they are inverse. Well, I don't have to you're not going to do an entire chapter of just a whole bunch of composites, as much as I know you guys loved it last section. But what we're doing here is I'm going to tell you how to find the inverse, okay? In this case, I'm going to switch all x's and y's. So if all the x's I'm going to turn into y's and all the y's I'm going to turn into x's, and then I'm going to solve for y. Okay, so basically I'm doing the opposite. Since y was originally isolated, now x is going to be isolated, but it's going to turn into y. And you'll see what I mean. But those are the basic steps. So go ahead and write this down, do your vocabulary, we're going to do an example, and hopefully you'll better understand. Alright, so in this equation, for the example, it's telling us to determine if f of x is the inverse of g of x. Basically it's asking us, is this an inverse of this? Now, I can do a composite of this and see if I end up with the letter x. I could do that. It'd take a little longer, but what I can do here is I can just take one of the equations. Let's say f of x. And I'm going to try to find the inverse. So when I find the inverse, if the inverse matches what this looks like, then they are inverses of each other. But if it doesn't match, then I haven't found an inverse just yet. But what I know is that I need to switch. The first step tells us to switch all x's and y's, but I have an x, but I don't have a y. But if you remember, and hopefully you do because it's a big part of functions, f of x, okay, is the same thing as saying y. So this is y equals 3 over 4 x minus 6. Same thing. So now what I'm going to do is I'm going to change all my x's to y's and all my y's to x's. So this is a y, I'm going to change it to x over 3/4, and this is a x, so I'm going to change it to y minus 6. Now that I have this, I'm going to go ahead and solve for y, isolate y. Let's see if we can do this. My first step is to take 6 and I'm going to add it to both sides. Okay, because when I'm trying to solve for something, I'm going to do the opposite. Okay, usually I'm going to get rid of all its friends first. I'm going to start with plus or minus, the opposite of the order of operations. Okay, in the order of operations, plus or minus is last, but when I'm solving, I do opposite. So I do x plus 6 equals 3 over 4 y. Okay, so what I'm going to do here is I'm going to go ahead and take this and I'm going to multiply both sides by 4. And when I do that, okay, this and this cancel out and I end up with 3y here. And since I take this, and because I'm multiplying the other side, I have to put it in parentheses. So I'm going to go ahead and distribute 4x and then plus 24. So again, what I did is I have this fraction, so I'm going to first multiply both sides by the denominator because this is being divided by 4, so I need to multiply opposite. Multiply by 4. But I have to do whatever I do on one side, I have to do on the other side. So in this case, I have to multiply by 4, but not just one of the terms, all the terms. So I have to take this 4 and then I have to distribute it to each one to get this. And the reason being is because I need to keep everything balanced. Remember, if I just multiply it by just one term, all of a sudden the equation changes and I'm no longer keeping with the rules. So then, after I do this, I need to then finally get rid of 3. 3 is the last thing. Since it's being multiplied by 3, I'm going to divide everything by 3. This cancels out, leaving y by itself. Okay, and I have this. What I'm going to do with this, and I'm going to take 3 and I'm going to divide it by both sides so I can separate it. Okay, because if this was one whole one, but it's not, so I'm going to do 4/3, put it under that x, and then I'm going to put it under the next term. So anytime I have this, I have to put it under every term, and the term is multiplied, is separated by a plus or minus. 24/3, and since y is by itself, is right here. Okay, 4/3, 24 divided by 3 is the same thing as 8. So plus 8 equals y. Okay, so this is my inverse. And since g of x is the same thing as y, I have the same equation. Even though this is on this side, it doesn't really matter, as long as this matches with this. 4/3x plus 8, once I find my inverse. So this is, the inverse does match this, because g of x is also y. So this is, yes, they are inverses of each other. Now if they were different, let's say this was a 5 instead of a 4, you know, and they had just slightly missing, close is not the same thing as exactly equal. So they need to be equal. Alright? And so once they're equal, then they are in fact inverses. So go ahead and try page 394, number 4. 394, number 4, and we'll go over it if you have any questions in class. Thanks, guys.